A very warm welcome to you. This is Dr. Zulfikar Kassam. I actually teach at the University of Toronto and the University of Phoenix as well. So the topics we'll be discussing here, the syllabus is going to include data communications networks, the internet, protocols and standards, transmission modes, categories of network topologies, and types of networks. Then we'll talk about the network models. Then we'll cover data signals. I won't read through each and every point in here, but you can see there's quite a lot of data signals we'll be covering here as part of this course. And then we'll go on to digital signals, transmission media, and using telephone and cable networks for data transmission. So that's quite revealing in terms of how things progressed from where we were to how we are today and all the things we learned in that process. And then we'll go on to looking at the different layers of the OSI model in a lot more detail than you have been accustomed to. So this information is going to be really key because the detail that I'll be covering this in will be way better than what you will see in even a Cisco course. Even if you do a CCNA course, the details I'll be presenting, it'll be more like university level course. And when I was trying to do some research and who teaches this course at this level, I found University of California or California, Caltech or University of California. They teach these type of courses with this level of detail. And then finally, we'll talk about the application layer. So without further ado, we'll try and look at the first section, which is Introduction to Data Communications and Networks. Okay, so let's go on to data communications. So when we talk about data communications, let's try and define what is data communications. Data communications is the process of using computing and communication technologies to transfer data from one place to another. Data communication enables the movement of electronic or digital data between two or more network nodes, regardless of the geographical location, transmission medium, or data content. So this we are really emphasizing the fact that data communications involves the movement of electronic or digital data, right? So what type of technologies do we need to be looking at, right? What are the data communication technologies we need to study? Data communication technologies, here we are talking about telecommunications, could be computer networking, it could be radio satellite communications. So they vary quite a bit in the different types of communication technologies we have available to us in today's world. Data communications usually requires the existence of transportation or communication medium. This is very important. Now, the actual medium could be quite different in different cases, right? The whole idea is there is a transportation or communication medium between nodes wanting to communicate with each other, such as it could be copper wire, could be fiber optic cable, could be wireless signals as well, right? So there are different communication medium. Of course, in the case of wireless signals, the air is the communication medium through which those wireless signals get transported. Now, when we talk about the data communications, let's look and break it down to the different components of data communications. The first and most important part of data communication is the message itself, it's the information that you are trying to move from one place to another. So the message is the most important part of data communication. Then, of course, there is the medium. This is the medium, is the means by which this message will be transferred from one place to another. So we have the message, we have the medium which we're going to be using to send this message. Then there will be a sender, right? And there'll be a receiver. So if we look at the different components of data communication, there'll be the message itself, there'll be a sender, there'll be a recipient, the receiver or recipient, and there's the medium over which the information will be transported. And finally, there's the protocol. Which protocol are you going to be using to send data? It's going to be HTTP, it's going to be HTTPS, it could be FTP, yeah, all the different protocols that you can use to send data, right? So now looking at the components of data communications, let's kind of look at it in a little bit more detail. The message itself, which is the information or the data to be communicated. The popular forms of information would include text, could be numbers, could be pictures, could be audio, could be video. And then there is a sender. The sender is the device that sends the data message. It can be a computer workstation, a telephone handset, a video camera, and so on. Right? Then there is the receiver or the recipient. The receiver is the device that receives the message. It can be a computer workstation, it could be a telephone handset, could be television, and so on. And then there is the transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. Some examples of transmission media include twisted pair wires, coaxial cable, fiber optic cable, radio waves, and microwaves. And finally, there is a protocol. A protocol is a set of rules that governs data communications. It represents the agreement between the communication devices. Without a protocol, two devices may be connected but not communicating. Just like a person speaking French cannot be understood by a person who speaks Japanese only, for example, right? So we need to have the same protocol for communication. As I mentioned, some of the examples could be HTTP, HTTPS, could be SSH, right? Could be FTP, and so on and so forth. Now, in terms of data transmission modes, let's look at the modes itself. The transmission modes define the direction of data transmission. Okay. Basically, what it does, it defines the direction of flow of information between two communication devices. Every data transmitted on the communication channel has a direction. This direction between two communication devices is defined by data transmission modes. So now let's have a look at the different forms of data transmission modes. But before we go there to the next slide, we have to understand that the transmission mode is a mechanism that decides the direction of data, means in which direction the data will be flowing. Okay. Now let's have a look at the different forms of transmission mode. Transmission mode can basically be broken into two categories. One is simplex form of transmission. One is the duplex form of transmission. In the simplex form of transmission, data basically flows in one direction only. For example, here A to B. So A is a device, B is a device, and the direction of flow of data is only in one direction. So A can send data to B, but B cannot send data to A. Or more commonly, you'll find duplex forms of transmission. But within the duplex forms of transmission, you will be categorized into two different categories. One will be half duplex. In half duplex, basically what happens is A can send data to B, or B can send data to A. So there is a possibility of flow of communications in two directions, but it only happens in one direction at a time. So both directions possible, but in one direction at any given time. So either A is sending data to B, or B is sending data to A, but they both cannot send and receive data at the same time. Conversely, in the full duplex situation, you can send data simultaneously in both directions. So A can be sending data to B, and B could be sending data to A. So this is happening simultaneously. Okay, so let's look at some examples which will give us information on how this works, right? So in a simplex transmission mode, as we discussed, basically data is being sent in only one direction. So A to B only, right? Let's look at this example here. We have a computer, we have a keyboard, we have a mouse, right? And we have the computer, the tower itself, right? And obviously we have the monitor here. Okay, so let's look at which of these situations involve simplex mode of transmission, where data can flow only in one direction. So basically data communication is unidirectional. As we mentioned, in this mode, a sender can only send data but cannot receive it. And the receiver can only receive data but cannot send it. So examples here, as you can see here, is a keyboard or a mouse. A keyboard or mouse inputs information to the computer, right? It can only introduce input, meaning to say it can only send data. So you can see the mouse sends data to the computer based on its movements. The keyboard sends data to the computer based on the key that is being typed, right? So the sender is the keyboard or the mouse, and the receiver is the computer. The CPU or the CPU here, right, outputs to the monitor. So the monitor can only accept output. Now, of course, if this was a tablet or a touch screen, of course, then you have two-way communications. But in most cases, most of the screens do not have touch screens. So in a regular traditional screen, where you don't have a touch screen, basically information is traveling from the video card in here on the computer to the monitor. So that's again one form of communication in which the computer is the sender and the monitor is the receiver. Are there any other examples of simplex mode that you can think of? I'll let you think for a few seconds before I give you some answers in here to ponder over it. Okay, computer to printer, right? So in most cases, the computer is printing to the printer. It's one form of communications. There's a speaker, there's the microphone, and there's the radio and TV transmission. So these are all great examples of simplex transmission mode. Then there is half duplex transmission mode. In the half duplex transmission mode, what we noticed is that A can send data to B, or the important part is or B can send data to A. But it cannot send data simultaneously. So only one person is sending and one person receiving. Once that finishes, the other person can send and the other person can receive. So in half duplex mode, each mode can transmit and receive, but not at the same time. So that's the key word, not at the same time. When one device is sending, the other can only receive, and vice versa. The half duplex mode is a one-lane road with traffic allowed in both directions, right? When cars are traveling only in one direction, because let's say there's construction going on and there's only one lane open, so there'll be a traffic person there trying to allow one direction to flow, and then it stops that one direction from flowing and allows cars to flow in the opposite direction. So when cars are traveling one direction, cars going the other way must wait. So the half duplex mode is used in cases where there was no need for communication in both directions at the same time, or at one time it was difficult to allow that, right? So classic examples are walkie-talkies, right? Citizens band radios, browsing the internet, USB version 2 also allowed communications only in one direction at a time. Note that USB version 3 introduced full duplex communications. And then there were hubs. So we'll talk about hubs, switches, and routers at some time. But hubs, all devices connected to the hub share the same transmission medium, which is typically a twisted pair of copper cables. And they must contend for access to that medium. So as a result, only one device can transmit data at a time, making Ethernet hubs half duplex devices. And then there is full duplex devices, right? In the full duplex mode, data can flow in both directions at the same time, means the device can send as well as receive the data. The data flow is bidirectional, and both sender and receiver can transmit and receive data simultaneously. Classic examples of that are the telephone. There is the router here and two switches, and there is the duplex fiber optic cable. Thank you, and we'll continue next time.